morning, students. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we have discussion on definitions and terminology on mission design. So what are the important definitions related to design and terminology also we should remember. So we will discuss today. So first of all, so what do you mean by mission design? So mission design is actually defined as the use of scientific principles and technical information and imagination in the description of a mission. Suppose we want to design a new product, so new mission. So you should use the scientific principles and technical information about that particular product. You have to draw the imagination diagram for a particular mission. But that should be give useful work with maximum economy and efficiency. This process is called as mission design. And also, you may be defined in another way also mission design as the creation of new design or improving the existing one. It may be entirely new product that is said to be your own design or existed, so already previously existed. Suppose you want to design a post of petrol engine. So already a lot of petrol engines are available. But you take that one design and modify. So you can modify the piston, you can modify the connecting rod or crankshaft, any one component or entirely. That also said to be design. So that is your design. So you have taken existed one and then you modified with some other material or some other mechanism. So whatever may be, you may be implemented. This one also called as a design. And mainly the design is a decision making process to make a useful product, to prepare a useful product that should be useful for society. Suppose example, car. You want to design a car. So what is the need of car? To transport the passengers from one place to another place. Suppose another example, pump, water pump. First one is car and the second one is water pump. So you want to design this water pump. For what purpose? To lift the water from low level to higher level. So to perform the specific function with the maximum economy and efficiency, that should be give good efficiency. This process is called as a design process. So the mission design means this design decision making process is used for mission to design a mission. So that is called as mission design. And the design of mission elements. Suppose you used the process for mission elements. A machine having a lot of parts. Suppose you take example lathe machine. So lathe machine is having a lot of components like lead screw, carriage, headstock, tailstock, tool post. So many bolt and nuts. So many components are there. Each and every component you have to design before assembly. So that also called as design of machine elements. So what are the basic requirements of machine elements? Strength and rigidity, and wear resistance also major requirement for machine elements, and the component also always should be minimum dimensions in weight, and then manufacturability. The component should be manufacturability. So it is manufacturability means it's casting or machinability, the forging, etc. All these process comes under this manufacturability, and the safety purpose, and then conformance to standards. Always you use standard components and standard dimensions, and reliability. So this one also very important factor requirement for emission elements, and then maintainability and minimum life cycle cost. So whatever you design product, that should be maintainable. Otherwise, no use. Nobody will purchase. So that these all are requirements before going to design any product. Strength and rigidity, weight resistance, minimum dimensions and weight, and manufacturability, safety. All these points you should remember in your mind. So based on these requirements, suppose you have designed a product, so that the component definitely will success in market. In design process, the engineering materials are very important. The selection of material. The selection of proper material for the machine component is one of the most important step. So it plays a main role in process of machine design. For desired purpose, the particular purpose, you have to select the best material. That also should be a minimum cost. Which material is suitable for your design? First identify. So without knowing your properties, without knowing the mechanical properties or thermal properties of a particular material, you can't select. So that's why you should first study the properties of the material. Then only you select the proper material for our product. So factors considered while selecting the material: availability of the material is one of the main factor, and then mechanical properties and manufacturing considerations. So availability of the material, suppose you have selected one material, first you have to check it whether the material is available in market or not. Should be readily available in market. So that also to meet large quantities for the as per requirements. So if you want to design a bolt material, so suppose you have used mild steel. So the mild steel material should be available in market in large quantities. So that's why the availability of material is one of the main factor. And the next second one is mechanical properties. So already you know the mechanical properties of material. Many properties are there. I will discuss in later slides. Next, manufacturing considerations. So the mechanical properties are, first we will discuss one by one the definition. Toughness. So it is the property of a material ability to absorb energy before fracture takes place. Suppose you have applied a load, it may be a gradual load or shock loads or impact loads, but that material should absorb energy. So before fracture taking place, after some time, suppose if you are gradually increasing the load, keeps on increasing load, what will happen? After a certain point, the component will fail, the material will fail. That is fracture point. Already we have studied in a stress strain curve. So to avoid the fracture, so before fracture, so at yield stage, so that material should be material the capacity to absorb the energy, whatever applied load energy. So that property is known as toughness. Next property is malleability. It is the property of a material ability to deform to a greater extent before the sign of crack. So it means, suppose we are using ductile material, it gives some sign before cracking, before fail. So that is yield stage. So whenever the material entered into the yield stage, so it's a sign of after a yield point, it's a sign of crack. So in stress strain curve diagram, upper yield and lower yield points are there. So already we have studied in stress strain curve diagram, stress and strain. O to A, this point is frictional limit, and then slightly the line deviates. So here upper yield point, lower yield point, and the maximum ultimate stress, and this one is failure, fracture. Fracture point. So before fracture is a yield B and C, upper yield and lower yield. This is the ultimate stress, sigma U, ultimate stress. So malleability is a property to deform a greater extent. So material should be extendable without fracture, but when it is subjected to compressive force. So we are applying compressive force. Suppose this object is subjected to compressive force. It should be compressible. Clear? So compressible, so diameter will increase and the length will decrease. So that this type of property is called as malleability. Next, ductility. So deform to a greater extent, this one ductility is a property of material, ability to deform a greater extent before the sign of a crack when it is subject to tensile force. In this case, in ductility property, so applied load is tensile load and malleability is compressive force. Clear? So opposite to this malleability force. So I will show you diagram. So whenever the component is subject to tensile load, in this compressive load, this one is tensile load. In tensile load, length will increase and diameter will decrease. So applied tensile load. In tensile load, length will increase. Length will increase and diameter decrease. So this type of property is called ductility. The material is said to be ductile material. Next one is brittleness. It is a property of material. Shows negligible plastic deformation fracture takes place. So negligible plastic deformation without giving any plastic deformation, the component material will fail. So it means without giving any sign of crack, suddenly fails. So this type of property is called brittleness. For brittleness property, the example is cast iron. For ductility, mild steel. So load is suppose when a component is subjected to any load, plastic or this tensile or compressive or impact load, what will happen? Suddenly the component will fail. Breaks like this due to the brittleness property. So next one is hardness. So this property, the hardness also a property of the material, resistance to penetration or permanent deformation. Suppose you applied load, compressive load or impact load, that material should withstand the particular applied load. So resistance to that impact load and permanent deformation. So this type of property is called as hardness. Example, diamond, highest hardness material. So it diamond withstand the any type of load penetration, any type of load to be resistance to the penetration. We can't find any deformation in that material. Next one is strength. The strength property, it is the ability of a material so resist the externally applied forces. So whenever the component is subjected to any type of load, so applied force, the component or object should withstand without healing or breaking. Then only it is said to be the material have good strength. So already you know the internal resistance offered by apart to an externally applied force. Suppose you are applying external force, the internal resistance force is called as stress. Due to the internal resistance force, some deformation will be occurred in that material. The obtained deformation is called strain. The stress is called as the applied force is called as stress. So that's why while calculating stress is equal to load upon area, cross-sectional area. What are the units? The stress Newton per mm square or Newton per meter square. The component should withstand the external load. Next one is stiffness property. It is the ability of material to resist deformation under stress. So what is the parameter here? The modulus of elasticity is the measures of stiffness. load for unit deflection. So the ability of material to resist the deformation. So much deformed, material to resist deformation. So without giving any deviation in diameter wise or lengthwise, then only is said to be the material having stiffness. Next, elasticity. So it is the property of material to regain its original shape after a deformation. So after deformation, nothing but, so suppose you are applied load on a particular component, to suddenly remove that load. So what will happen? So whatever gained the shape due to this external load, whatever deformed due to the external load, external force, whenever you remove that load, so the material will regain its original shape. This type of property is called elasticity property. So this type of property desirable for materials using tools and machines. In mechanical machines, very important, this type of property. So a lot of loads acting on mechanical components. So it may be noted the steel is more elastic than rubber. Examples, the elasticity property materials. So elasticity property is nothing but whenever the external forces are removed, regain its original shape. Is called as a property is called as elasticity. So plasticity, it is opposite to the elasticity property. When a material is subjected to, when a component is subjected to external load, so deformation produced under external load, but the deformation is permanent deformation, not temporary deformation. So whenever removed the load, it does not regain its original shape. The shape of the object will change. This property is called as plasticity property. But this time, sometimes the plasticity property is useful for some operations like forging, stamping images, and coins and ornamental works. The plasticity is important. So deformation, that is useful deformation. So whenever the load is removed, so the component will not regain its original shape. The property is called as plasticity property. Next one is resilience property. What do you mean by resilience? So it is the property of material to absorb energy whenever the component is subjected to shock loads or impact loads. So it is measured by the amount of energy absorbed for unit volume within the elastic limit. So this one also the important for spring materials. So we'll calculate by using this empirical relation resilience or stored energy. Strain energy of do W into delta. So this one resilience property, due to the resilience property, some strain energy we produce in the component or material. So that is load, applied load and deflection. How much deformed, how much energy absorbed, the total energy absorbed you may calculate by using this relation. In spring materials, this property is Very, very important. Next one is creep property. When a component element or part is subjected to a constant stress, there is no change, not a variable, at high temperatures for a long period of time. High temperatures for a long period of time. So it will undergo a slow and permanent deformation called creep. So at high temperatures, so whenever the component is subjected to constant stress, so what will happen in the component? So it undergoes slow and permanent deformation after some time. So what will happen? The permanent deformation will be occurred in the component. That part is called as the property is called as creep. Generally, this type of property considered in designing internal combustion engines, boilers and turbines. So internal combustion engines, lot of components are there: piston, connecting rod, crankshaft, cylinder. So all these components are deformed under constant stress at a particular temperature. So that's why this property is very useful for automobile engine designs. Next, fatigue property. So very, very important. Whenever the material or component is subjected to a repeated stresses, so repeated cyclic loads, it fails at stresses below the yield point stress. Whenever the stresses are occurred below the yield point, then the component will fail after number of cycles. This type of failure is called as fatigue phenomena. So how to calculate this fatigue? By using a SN curve, and you can conduct experiments on a rotating beam fatigue tester. So whenever the component is subjected to repeated stresses, meaning variable stress cyclic loads, then the fatigue property will be occurred in the component. So all mechanical components, all mechanical components are subjected to this fatigue property, fatigue phenomena. So why? Because these mechanical components are always subjected to repeated stresses. Take example, connecting rod, shaft, and springs, and gears also. So connecting rod. The connecting rod is in machine in automobile engine. It is connected. The small end is connected to the piston, and the big end is connected to the crankshaft. So it always gives rotational motion, reciprocating motion convert into the rotary motion. It carries transfer the motion from piston to connecting crankshaft. So that is repeated stresses. The piston also moves from bottom to top and top dead center to bottom dead center. To and fro motion like this. Example, piston. So whenever the external load is acting here, so moves. This is crankshaft, connecting rod, and crankshaft, connecting rod. So that always the parts are subjected to cyclic loads. So that the fatigue property is very important when designing these type of components. You should take stress concentration factors and fatigue stress concentration factor theoretically, and then noise sensitivity factor, and you should multiply some other factors also. Already we have studied in stress concentration theory. So next term is interchangeability. So the interchangeability and standardization are very important in the design of machine elements. So actually the term interchangeability used for the mass production of a components within the prescribed limits of sizes. So some prescribed size limits of size. So the component should be some prescribed limit. So then only this term is interchangeability is applicable. Example, the shaft diameter and the wall size. The important terms used in limit systems, so that's why derived limit system. In this limit system, we will study what is the upper limit, what is the lower limit, what is the basic size, what is the nominal size of the component. Why? Because within these limits only the interchangeability is applicable. So here shown in figure, here shown the wall dimension and shaft dimension. Shaft having lower limit and upper limit. Upper limit and lower limit. The difference is called as, the difference between this upper limit minus lower limit is called as tolerance. So what do you mean by allowance? Allowance means the upper diameter of the upper limit of the shaft minus and the inner diameter of the wall. So the difference between upper limit and inner diameter, the upper limit and inner diameter of the wall is called as allowance. In this case, tolerance, whole tolerance, difference between upper limit and lower limit. Shaft tolerance, difference between upper limit and lower limit. So that is the upper dimension of the limit, shaft diameter minus inner diameter of the shaft, lower limit of the shaft. So like this, we will calculate tolerance and allowance. So in this, the basic size and nominal size and actual size are important. What do you mean by nominal size? So nominal size means it is the size of a part specified in the drawing. So whatever you specified in the drawing, the basic size is the all limits of variation are determined. The actual is nothing but the measured dimension of actual measured dimension of a part. Nominal and basic size are often the same. The nominal and basic size. See in this diagram, the nominal size 4 inches here and 2 the length thickness, and here 3. Actual is 3.5 and 1.5. So they vary the dimension. So the drawing, the size of the part specified in the drawing is nominal drawing. This is actual, in your drawing specified like this. But in actual condition, in actual manufacturing, it gives 3.5 and 1.5. So this is these dimensions are called as actual size. So that's why we should use tolerance. Have to give some tolerance zone. So there are two extreme possible sizes of the component. What are they? The upper limit and lower limit. The smallest size is called as lower limit. The highest limit is called as upper limit. So already I told you in previous slide. The difference between these two is called as tolerance. But allowance is the shaft dimension related to the shaft dimension and the hole dimension. How to give some allowance to this system or a shaft. The maximum upper limit, the difference between the upper limit and the lower limit of the wall. Allowance is equal to upper limit minus upper limit of shaft minus lower limit of hole. It gives allowance. So lower deviation. So already you know it is the algebraic difference between the minimum limit of size and the basic size. Minimum limit of size and basic size. Similarly, upper deviation is the algebraic difference between the maximum limit and the basic size. Next, in this diagram, so all terms corresponding to the basic size. So the deviations are measured from the line. This line is called a zero line. All deviations are measured from this line only. So here whatever shown there in diagram, this line is zero line. The above zero line and below zero line, some terminology are there. So the above zero line, this is a shaft tolerance. And then hole, size of the wall and hole tolerances. See here, upper wall deviation, lower wall deviation, and wall tolerance. Similarly here, minimum size of the wall shown here, and then size of the wall and nominal size, and minimum limiting of size of the shaft, and maximum limiting size of the shaft. The total you can show on this line above the zero line, so that the deviations are measured from the reference line. That line is called a zero line. Whatever tolerance, hole or shaft tolerance, lower deviation, upper deviation. Similarly, coming to the shaft tolerance, lower shaft deviation and upper shaft deviation. Lower one and upper from this line. Now, what do you mean by allowance? Already we know. It's already explained in the previous slide. Difference between the basic dimensions of the mating parts. So it may be value positive or negative. When the shaft size is less than the hole size, then allowance is positive. And when the shaft size is greater than the hole size, then the allowance is negative. So negative allowance or positive allowance. Suppose 0.05 and 0.02. the basic shaft diameter is 50 mm. So allowance given upper side the positive plus 0.05, 50 plus 0.05, so 50.05 mm. Lower one 50 minus 0.02, 48.0, 50.00 and 0.02, 8, 49.98, 49.98. So when the shaft size is less than the hole size, then allowance is positive. Shaft size is greater than the hole size, then allowance is negative. So remember this type of allowance. Next one is tolerance. So what do you mean by tolerance? It is the difference between the upper limit and lower limit of a dimension separately. So here shaft tolerance and holes tolerance are different. So give some tolerance to the shaft and give some value, tolerance value to the hole. That is based on your upper limit, upper size of the shaft and the lower size of the shaft. Suppose the upper limit is here, so 0.00 and lower limit is 0.004. The difference between these two is called as tolerance. So it means, in other words, it is the permissible variation in dimension. The tolerances are again two types. One is unilateral and bilateral. So when all the tolerances are given one side to the dimensional size, nominal size, that is called unilateral. When the tolerance is given to the both sides to the nominal size, that is called as bilateral. See here, given example 20 minus 0.04 and plus 0.00. Two values are there in positive and negative. Then it is said to be unilateral system of the tolerance. So it means here only negative side is there, the plus is 0, only one side. In industries, and it permits changing the tolerance value. So use this type of tolerances in industries. So when the tolerance value is allowed on both sides of the nominal size. See in this example given 20 plus 0.002 minus 0.02. This type of tolerance is called as bilateral system tolerance. So in this case, see, you can say this one is upper limit 0.002 and minus 0.002 is the lower limit. So difference between these two is called as tolerance. You may take another example, 20 plus 0.05 minus 0.04. So both sides to the nominal size, plus and negative. These type of tolerance are called as bilateral system tolerances. Next, in this, hole-based system and shaft-based systems are there. Now let us see the hole-based system. The hole-based system, the tolerances values or all tolerance values are kept related to hole only. So it means hole is kept as a constant member. So the lower deviation of the hole is 0. So here different types of fits also obtained by varying the shaft size. Hole is 0. Hole size is constant. There is no change. So different fits also obtained. Clearance and transition and interference fit. I will explain what I mean by fit in coming up slides. So then the limit system is said to be hole basis system. Whereas in shaft basis system, when the upper deviation of the shaft is 0. So always it means the shaft dimensions are kept as a constant. Different types of fits also available, obtained by varying the hole size. Here the hole size is varying, and then in previous case varying the shaft size, hole size, this one. So then the limit system is said to be on shaft basis. One is shaft basis, another one is hole basis system. So in this diagram shown, shaft hole basis system, here different diameter shafts are there, 1 and 2 and 3. Different types of fits also obtained. The first one is clearance fit. So a lot of clearance is there in between the hole and shaft. And 2, transition fit, to tightly exactly fitted. And interference, the hole shaft diameter is interference with the hole dimensions. So the interference shown in 3. So similarly for shaft basis system, shaft is constant here, the diameter constant, the hole size is vary. So this type of system is called as shaft based system and hole based system. Now coming to the fits. So it's nothing but the degree of tightness or looseness between two meeting parts. It may be sometimes loosen and tighten. So it depends upon this component, the shaft and hole dimensions. So that is measurable, the degree. So what is the clearance, what is the tightness between these two meeting components, the hole and shaft? It is nothing but fit. Suppose here you have shown diagram, shaft and hole dimensions. So you have to find out what is the degree of tightness. Is it clearance fit? Is it transition? Or is it interference? You have to find by according to the upper limit and lower limit values of shaft and hole. And also which type of systems is used. Is this hole based system? Is this shaft based system? You have to identify. So then only you can say this is a clearance fit and a transition fit and interference fit. So now we will see clearance fit. So in clearance fit, always there is a clearance between the shaft and hole. These two are here meeting parts, shaft and hole. So in this, see, these type of fits may be slide fit and easy sliding fit, running fits. Example, shaft diameter is less than the hole diameter. Always in clearance fit, there is clearance between this shaft diameter and hole diameter. It means the tolerance zone. This is the minimum clearance tolerance zone. shaft tolerance zone is always less than the tolerance zone of the hole. This is hole, this is for shaft. These type of fits are called clearance fit. So here the maximum clearance from inner diameter of the lower limit size of the shaft to the upper limit of the shaft. This is minimum clearance. Maximum clearance and minimum clearance. This is tolerance or allowance. So minimum clearance is upper limit of shaft, the difference between the upper limit of the shaft to the lower limit of the hole. Whereas in maximum clearance, lower limit of the shaft to the upper limit of the hole. Next, interference. In this type of fit, the size limits for the mating parts are selected. That interference. So interfered between these two mating. So the tolerance zone of the hole is entirely below the tolerance zone of the shaft. See, the tolerance zone of the hole is below the tolerance zone of the shaft. So it means, suppose this tolerance zone of the hole. The tolerance zone of the shaft is above the hole. So it means the shaft tolerance zone is above the hole. It means always the whole tolerance zone is below the shaft. Then only interference will be occurred between these two mating parts. So next one is transition fit. So what do you mean by transition fit? So in this type of fit, the mating parts are selected, and then either clearance or interference. It may be clearance or interference. May occur depending upon the actual size of the mating parts. So the depends upon the actual size. This is the shaft tolerance zone and hole tolerance zone. So the shaft and tolerance zones are, sometimes it may be clearance, it may be interference. These type of fits are called as transition fits, and generally it is depends upon the actual sizes of the mating parts. What is the actual size of the shaft and the actual size of the hole? Here you will see one simple problem. The dimensions of the mating parts are given like this. The two basic hole system are given as 25 mm, 0.2500 and 25.02 mm, and shaft is 24.97 and 24.9. So find the hole tolerance, shaft tolerance, and allowance. So already we have discussed about allowance and tolerance, hole tolerance, and shaft tolerance. So the hole dimensions are given 25 and 25.02, lower and upper. Similarly, for shaft dimensions are lower and upper given. So given data, lower limit of the wall 25 is lower and upper. Upper and lower are 25. Lower is 25 and upper is 25.02. Upper limit of the shaft is 24.97 and 24.95. So now find wall tolerance. So wall tolerance, the difference between the upper limit of wall to the lower limit of the wall. So here given 25.02 minus 25. So it gives 0.02 mm. Similarly, shaft tolerance. Upper limit of the shaft minus lower limit of the shaft value. So upper limit of the shaft is here 24.97 upper limit and 24.95 lower limit. This is for shaft. So the difference between these two, upper and lower, 24.97 minus 24.95, it gives shaft tolerance. Shaft tolerance and wall tolerance are calculated. 0.02. Next, allowance. So allowance is lower limit of the wall minus upper limit of the shaft. Lower limit of the shaft and upper limit of the lower limit of the wall, and upper limit of the shaft. These two. The difference between these two, upper and lower, is called allowance, already shown in this diagram. So you can find in this previous diagram allowance, upper limit and lower limit. Okay, next one is, so lower limit of the wall and upper limit of the shaft, calculate, substitute the values, and obtained value is 0.03 mm. So like this need to calculate. So what is the general procedure in machine design? So already design definition have learned, and what are the various consultations you have to take in for designing, and so what is the procedure for selection of material, already we have learned. Now in this, what is the process, the design process, where to start, where to end? So that is very important. So without without following the procedure, suppose we have designed a component, so that is meaningless. So definitely the component will fail. The first one for any design, need or aim. So what is the need of your product? What is the aim of your product, design product? Which one is, which product is, which design is you are going to be implement, design? Which component are going to be designed? What is the need? Identify. So that means first define the problem completely. So for this, recognize and specify the problem. So after specify the problem, need and aim, synthesis. So where to get this data? From market survey. Suppose we are going to design a new pen or new vehicle. So first identify what you are going to be design, and go to market and conduct market survey. So gather information from various peoples and customers and list out, and finally make a statement. After that, identify which type of mechanism is required for our product, our design product. Is it reciprocal or rotary motion, slider crank mechanism? So various mechanisms are there. Which mechanism is suitable for our identified problem? So select one mechanism that gives the desired motion and form the basic model. After identify the mechanism, now analysis of the forces. Which type of forces are acting on that particular component? Analyze. Suppose we are going to be design piston. So which type of forces acting on that piston? Identify. Like one is thrust force, another one is the combustion forces, gas force, and inertia force. So all these forces will act on that particular piston. So analyze. After analysis of the forces, now identify the material. Synthesis over analysis of the force and material selection. Already we have discussed in starting slide. The selection of material is very, very important. So select proper material for your problem and for your design and design of elements. Elements, individual components. Supply those materials for individual components or elements. So that's why in this stage, the material selection, you should know the properties of materials. If you don't know the property of material, you can't select for particular for desired design. Next one, after design of elements, determine the stresses and then sizes, the dimensions of the components. And the static failure or deformation does not occur. So it means determine the stresses and the dimensions according to the design procedure for static loads. And then prepare one prototype model and test it. If not satisfied your design criteria here, while doing this design of elements, go to previous step, material selection, and again modify your material, and then calculate stresses and all remaining dimensions, and then fix it. If satisfied the conditions, fix your design parameter dimensions. So otherwise, once again go to previous step and modify till satisfy the conditions, and then modify the sizes to easy construction and reduce overall cost. After modification, you obtained one final solution. So with the help of that final dimensions, prepare a detailed drawings. That is mission drawings, individual component mission drawing, part drawing. After that, these drawings goes to the production department for manufacturing. Right? So after production, the components release into the market, and after 1 year, 2 after releasing this component, again conduct one survey, feedback from the customers. So again modify it if any changes, any extra requirements are there, and apply this procedure. So like this, you have to apply the design procedure for designing a component or a machine. For any design, this procedure is important. You should follow. So then only your product, your design will be success in the market. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.